The topic is large sample hypothesis test for the mean p-value method. In other words, the sample size n has to be bigger or equal than 30. So let's read the definition. First part of the definition, a null hypothesis H0 always contains the equality sign. The alternative hypothesis is the complement of the null hypothesis, and it contains the strict inequality. And then the logic here is if the null hypothesis is not true, then the alternate hypothesis is true. In other words, if H sub 0 is probably not true, then H sub A is probably true. So that's what we're going to use for logic. So let's do the example. In your work for a national health organization, you are asked to monitor the amount of sodium in a certain brand of cereal. You find that a random sample of 52 cereal servings has a mean sodium content of 232 milligrams with a standard deviation of 10 milligrams. At the level of significance alpha equal 0.04, can you conclude that the mean sodium content per serving of cereal is greater than 230 milligrams? So what is the claim? Can you conclude that the content per serving, the mean is greater, means strictly bigger than 230? So you always start with the claim. Well, this is step one. Step one, always write the claim, H sub 0 and H sub A. So the claim, I always start with the claim. And remember, the claim sometimes is going to be in the null hypothesis, sometimes it will be in the alternate hypothesis. In this case, what does the claim says? The claim says that mu is strictly bigger than 230. Now, according to the definition, the alternate hypothesis right here will always have strict inequality. So therefore, I know that this is H sub A. If it was or equal, then I know it's H sub 0. Now I gotta find H sub 0. H sub 0 is the complement of H sub A. So we're gonna be using this, right? The complement of strictly bigger is less or equal. So H is less or equal than 230. This is the null hypothesis. Is the complement of the alternate hypothesis. Now what's next? Let's look at step number 2. Step number 2, we always look at the sampling distribution of X bar given that mu, this is mu, is equal 230. In other words, remember from the sampling distribution, we know that mu X bar is just going to be equal mu, which is in this case 230. So what's the logic here? The logic is, assuming H sub 0 is true, how likely that we would observe X bar equal what? What did we get for X bar? A random of 25. Yeah, so this is the X bar, 232. X bar equal 232 milligram. Let's talk about F. So let me read the problem again. You find that a random sample of 52, so we know n is equal 52, cereal servings has a mean sodium contact, so X bar is equal 232, and a standard deviation S is given to be 10 milligrams. So the first thing we do, we know mu X bar is 230. We knew the standard deviation. How do we find the standard deviation? The standard deviation of X bar, by definition, is standard deviation of the population over square root of n. Since we don't have standard deviation of population, we can approximate it by using S, standard deviation of the sample, over square root of n. And this happens to be equal what? 10 over square root of 52. Now if you use a calculator, this is about 1.387. Alright, so we know this is 1.387 or 89 or 39. So what's the logic here? Assume h sub 0 is true. How likely that we will have x bar be 232? So assume x bar, it's right here, x bar is equal to 232. So we want to know how likely we were going to get the sample mean in our sample. So in other words, all we need to do is find this probability, right, this area. So we need to find the probability of x being at least 232 or bigger, so bigger or equal than 232, given that mu is 230. So how do we do that? We can find this area by going from 232 to like 1,000 or 10,000. So 232 all the way to 1,000, use normal CDF. 1,000 or 10 to 1,000 is enough. It's more than 4 standard deviation. And then the mean of x bar is 230. The standard deviation is 1.387. Right? So if you use your calculator, you're supposed to get 0.0746. So now let's look at the definition. Definition says if p-value, and this is the p-value, let me write it here, p-value is equal to 0.0742. So according to the definition, if p-value is less or equal than alpha, we reject a 0, but if it's bigger than alpha, then we fail to reject. I mean, you can tell this is bigger than alpha is what? Let me see. Alpha is 0.04. Alpha, which is 0.04. Right? So therefore, we fail to reject. So we fail to reject h sub 0. By the way, I mean the previous example or this example, when we call this test, because the probability we're looking for, the area is on the right side, we call this a right, let me write it here, a right tailed test. The previous example we did is called left tail test, just because of the area of the probability is on the right side. Alright, now we're almost there. We need to do the interpretation. So we know the claim is in the alternate hypothesis. Since the claim is in the alternate hypothesis, we're right there. So we fail to reject. So therefore, we fail to reject a sub 0. So therefore, this is how we're going to go. It's kind of like you're going to say there is not enough evidence to support the claim. However, it's just because the way they ask us the question, I'm just going to change it a little bit. Because they say, can you conclude that the mean sodium content, blah, 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 is greater than blah, blah, blah. So what I'm going to say, I'm going to start at there is not enough evidence. So I'm still going to say there is not enough evidence. Should I say to support the claim or to conclude? In this case, I'm just going to say to conclude because they asked me that question. But usually you say to support the claim, blah, blah. So to conclude that the mean sodium content is greater than 230 milligrams. And that's it for this example.